Hi, good day. My name is Jerry Abraham. I'm really excited to present my project. This is a containerized RAG AI agent for URA bank. Okay, so that's like a fictitious bank. On RAG plus Gen AI, I have already created a video. I will put the link for that in the description. So I'm not going to go so much into the theory of RAG Gen AI plus Gen AI, but more so about my project and what are the things that I've used, what is the background, what is the problem, and how I've tried to address that problem. Okay. So here I've tried to get grounded truth and reality for the RAG GenAI agent. So I'm actually using the private knowledge or the private database of URA Bank, right? So the employees need information about certain products, and this is primarily related to loan. So we have a small portfolio or data set that we are looking at, or database that we're looking at. It is essentially in a TXT file, right? So this is a demo model, but it is containerized and it uses the entire RAG AI end-to-end framework. So this has been deployed on Docker. So I've used Docker Compose. I've done it in Ubuntu, and I'm going to show you all of that in terms of the Docker image, the instruction, the image, the container, how we are using Docker Compose, how the network has been done, and how we are running these containers on the same network. And I will simplify the whole thing. Uh, just stay with me, and you will see how this whole thing unfolds and how you will be able to create the same thing for yourself. I'm going to share links for my GitHub account where I've already posted all of this, so you can have a look at the code and understand, and also look at this video where I've put in a lot of comments which I will take you through, and so you can easily understand this. But the best thing would be to kind of experiment it yourself, right? So coming back to uh, the project, right? So we are talking about a bank database. We are going to use LLMs. So we are also going to look at the pre-indexing part. So it's not just the RAG, but also the pre-indexing is also coming in over here. In the real world, it will be a separate stage in itself, but I've put this over here so we understand the overall end-to-end flow. So I have used Fast API, which is a web framework from Python. We will understand more of that. And that helps you, get your endpoints, which is essentially a URL. And we've done this on Uvicorn. And for tunneling, we used Ngrok. So essentially, I'm running this on my on Google Colab, right? So my development and testing has been done on Google Colab primarily because it gives me more RAM. My laptop has less as compared to Colab, and so we're running it in a local host. Now, if I want to make it public, I can use Ngrok. So I can just share that link, and Ngrok is provides us a secure tunnel for that purpose. So I will update, if possible, I'll try and update this slide. So essentially, when we talk about tunneling, we're using Ngrok over here. So the developing and testing, we have used Ngrok, but for the production itself, I've used Docker, right? So containers. So this is an actual containerized. So if I give you the image, if you understand that, and we'll come to that, you just have to use the same structure. You don't need any of those libraries and dependencies that we would typically read, right? So essentially, I've created all of this in Python with all the pip installations. You will need all of that. But once we create an image, all you need is the image and the YAML file, the Docker Compose, and obviously the database, right? Which is here we have used FAISS. So for database, vector database, we use FAISS, which is your Facebook AI similarity search. For orchestration, we use LangChain, LangGraph. For the LLM, I have used models from Hugging Face. They are all free. So my constraints have been use resources that are free, use resources within the RAM and all that I have, right? I've also used another model, a Microsoft model, and that I could run primarily because Google in the runtime actually provides a T4 GPU. But in Docker, I couldn't because I have to run it on my local machine. Right. So if you have the kind of infrastructure, RAM, and a GPU and all of that, then excellent. You can use some really good models. Right. So the model that I have used is trained on about 780 million parameters. But say for instance, if you were to look at GPT-5, that will be somewhere in trillions. So that's the kind of difference that we're not billions, trillions. That's the kind of difference that we're talking about. So it's while it is called large, but in comparison, seriously not all that large. Then we have the embedding model, right? I've used all mini LM L6 V2 and for vector database FAISS. Yeah. So this is the basic construct of our entire working. So these are the things that have been used to create this. So now let's get into the Python code and unfold all of this. So so that becomes easy for you. So let's look at that. So there are two scripts that we're going to look at, and I have already run all of this because so you can actually see what the output looks like. Otherwise, it's going to take some time, especially considering that my infrastructure is or my resources are limited. It's just a 4 GB RAM. Otherwise, if you have like a 32 GB RAM, or in fact, even if I were to run it on Collab, Collab gives us about something in the range of you can actually see that it's 12.67, right? So that is what is available. So this is on Google Colab. So these are my so this is the RAG, okay, the RAG API. Okay, so there are two. Okay, the other thing that I missed is so our backend, the LLM and all is using RAG, but in my front end, I'm using a UI which is Gradio. Okay, so I'll come to that script as well. So there are two scripts that we will look at. So this is all the pip installation that is used. Okay. Uh, this is primarily because I'm connecting. Okay, so here what we're doing is I'm just connecting to my drive and reading the authentication, the tokens for Ngrok. We have to run this particular script because Ngrok requires of us to use their upgraded version. Okay, so this is a standard. I'm just keeping this out here so you can actually see. So we have to use this, and I'm using my tokens, which are there in my JSON, which is there in my Google Drive, right? So there are a lot of videos where you will see, how Docker installation or how an Ngrok account or even a Hugging Face, how you get in over there. Very simple and very good videos are available, which where you can look and pick up on all of those. But here we'll try and primarily focus on the project and the code, right? So, I hope you got a handle on the construct. So we've got the entire rack that we spoke about. So that's the backend, and in the front end, I've got a UI. I've used Gradio over here. So we're going to look at both the scripts. Right, so this is okay. So now with this out of the way, these are the libraries that we are having. Sys for systems, random, where we're going to use random integers, threading to start our threads. Nest, Essentio. This is primarily so we can run the. I have written a lot of comments, so I'll take you through that. So to run asynchronous functions, right? So essentially, when you have a function call, it is not going to so it can run. If it is not, uh, it will run and you'll have to wait. But here what it does is it just starts, and then it will not wait. You can move on to the next thing, and when this is done, it will come and pick it up from there. So that's how it works. Then you got some of these other libraries, and then we've got typing, typedict, and this is your dictionary and any. So in your dictionary, I'm assuming you have a little bit of background on Python. Okay, so you got the key and the value, right? So string and integer. This is what we're defining. In typedict, you can actually define your own customized dictionary. Okay, so look at this. So here is some of my comments. Okay, a class where I'm using this. I've defined two variables out here. One is a string and integer. So if we actually run this, the string and the integer, this will come as okay, and this will come as missing value. Okay. Now let's look at the any part, importing any. So this, okay, the first one will be, okay, so this is string, and the rest, this is integer, and this is a list. So any means absolutely any kind of data type, right? So that is what it is. Then we are using Pydantic import base model. Okay, so this is primarily so that we can create our own. So this is from the Pydantic library. The main thing over here to focus is when we create a class using base model. Some of the things that it does is it does validation. It does that it belongs to this data type. It does conversion if it's of a different, and it also flags off errors automatically. Okay, so it does all of this. So just look at this. Okay, so we've got class, user, base model. Okay, so one is string, the other is integer. When you run this, you've got the string and the integer, so this is fine. Here you've got a string and a string, so it'll auto convert. Here it'll say, hey, the second one is missing. Okay. So we're just still in the libraries that we imported. This is for the pin code. So here we are doing a couple of things in our RAG. One is we are asking queries. Okay, so the employee is asking queries. About this loan, about a personal loan, how is it? About a car loan, some information. What are the working hours? So it's a limited database. And this is for if we want, so we made provision where if let's say if it's for a customer or whoever that may be, you want to go and visit a branch. So here is a bank with a pin code, and you can actually go there. So that's why we provided this, which will give you like a pin code map location. Your fast API, your web framework. Okay, so all of these libraries, I will take you through some of these. So API. So coming to our fast API. Okay, so this is primarily where two programs can talk to each other. It's like a messenger system. So think of it like a restaurant. Okay, so user is asking for food. So that's a request. The waiter is the API that takes the request to the kitchen. Kitchen is the backend system, makes the food, process the data. Okay, and the waiter brings the food back to the user or to you, which is the response. So that is essentially right. So a messenger system or a program to talk to each other. So fast API is you know like one of the best, most simplest web APIs, which is available in the Python framework, which is for sending and receiving data over the internet. It's pretty high performance, does automatic validations. It's built on Starlet Web and uses Pydantic for data validation. Okay, so it handles HTTP requests like your get, post, put. Okay, so you will see all of this, and the returns response is JSON. So this also has this Swagger UI, which is where the endpoint testing happens, and I will actually show you that. So it's very nice. So you can actually test it out even in the UI. Okay, which is provided by Fast API. So now this can take apparently up to 33,000 requests per second. In comparison with Node.js, it's about 35,000. Go is about 40K, and Flask is about 3,000. So it's pretty slow in that sense, relatively speaking. So, and the Swagger UI, okay, which is for the endpoints testing, which is from Fast API. Ngrok is for our tunneling, like I mentioned before. So this fast API is gonna use Uvicorn, which is a server that will for the endpoints over the network. And tunneling, Ngrok is just a tunnel, so it's everything is running on the local host, is running on the machine, and Ngrok is just a secure tunnel, okay, that makes this public. So someone outside, if you just give the link, they can also use that. Okay, so yes, so under the hood, Fast API uses Uvicorn to actually serve the endpoints over the internet. we spoke about this, and this is the actual line of code which we will look at. So fast API app is equal to fast API. Uvicorn.run, we are loading this over here. I'm using host is 0.0.0 port. We will look at this. We are actually using random.int. So we'll come to all of that. The rest is okay. I will touch upon all of these. This also I will come to a little later. Okay. So this is our code. Okay. So after looking at some of our libraries, so this is where, so I'm setting some of these variables. This is where I'm eventually going to load my Ngrok authentication. So this is really required. You will get it from Ngrok when you create an account. It's all free. Everything that I've used is free. Okay. That's why it's been shared free. So yes, and HF token not required, but you get warnings. That's the reason I actually put this. This is where we're getting our code. So random it, anything between this, it'll actually generate and pass it on over here. This is our LLM that we're using. Google Fan T file large, and the embedding model is this. This is a sentence paragraph embedding model, and the output vector dimension is about 384. Some of the other ones are something like 3024 vector dimension. So how do I put this? So you have your x, y, z coordinates, 3 dimension. Think about translate that to 384. And there are embedding models which have 3000 plus 3024 dimension kind of a thing. So this is pretty small in that sense. Right, so we're mounting the drive. So I'm going to take data. So this is where my txt file is. This is my JSON file. This is for my for the authentication code, right? So that's where I have this. So it's pretty standard open. Okay, so we're passing all of this. These variables have been created earlier. If there are exceptions, file not found or JSON this thing. So okay. So we will be reading all of these parts, okay, and the config file. Right, and this is the fallback in case our data is not available. So this is just the fallback. We don't need this. I've also primarily when I was just began doing it, that's where I actually put this. So if our knowledge base is not getting loaded or there is a problem, okay, this is not there, then we use this as the fallback. Okay. This I already mentioned earlier. So we are doing this so that it allows, this is primarily for Google Colab. Others you don't need this. So allows to run nested asynchronous function. Okay, so this is, we are using the transformers. Okay, so if you looked at this library, okay, this is from transformers, from your Hugging Face. So this is the auto tokenizer, and this is the auto model for sequence to sequence LM. This is a pipeline. So the pipeline automatically loads both of this, even if you, but we're trying to use a customized version. Okay, so the pipeline has both of this in default, but it'll pick up anything from transformers, Hugging Face, right? So where were we? Yes. So this is our model pre-trained. Okay, it's a pre-trained. Our model name, which we passed on earlier, that's a token, and this is our tokenizer. Yeah. So that is also from pre-trained. This is the pipeline that we mentioned. Okay, so this is a text-to-text generation. Okay, so this is where our model is passed over here from here to here, and these are max tokens to be generated. Okay, the model will generate this so many number of tokens. uh, do sample equal to 2 basically tells that whether you should be random in the next word pickup, right? Or false means not random, very deterministic. Temperature works only if this is true. Okay, temperature simply tells how much random, okay, less or deterministic. So I put some comments around that. Okay, so let me take you through this. Okay. So every time our model generates the next word, doesn't think in terms of sentence. Okay, picks up a list of possible next tokens with probabilities. So let's say it is the cat sat on the. So it has these probabilities: mat, floor. Okay, so these are the words with a set of probabilities. So if it is false, then there's no randomness. It just picks up the first. Okay, the one with the highest probability. If you make it true, then based on the temperature, whatever we say, if you say point, the lower the number, more deterministic it becomes. Okay, so slight randomness. So that is what it is all about. Higher numbers are this. Okay, so that is more creative. So it'll actually pick more from the probabilist, right? And repetition. This is we just passing penalty so that there is no repetition. Okay, so this parameter tuning is pretty important when it comes to the LLM. And these are some additional parameters that we are passing. So D type defines the data type of the model. So float 32. So whatever is the default, stick with it. Don't change that. And then US token ID tells the model when to stop generating text. Hugging Face pipeline. So this is a class which is like a wrapper for our pipeline. So this is the LLM, basically the LangChain compatible LLM. So like a wrapper. Okay, so we've done the okay. So this is from LangChain. These two. So it's like a wrapper for our pipeline. So we've got that, and then we pass some additional this thing. So when to stop. Okay. Uh, so this is all in a try, very simple try except and raise error. Okay. So